Okay, so let's get back to where we were yesterday. There were several. We only considered a single interaction yesterday, right? Where we had controllers, we had a model, and we were feeding the controller a simple string, maybe 3 space 4. Maybe plus 3 4 or something, and then the controller then somehow parsed this, converted these input stream, and passed it on to a model to verify that indeed 3 plus 4 was 7, right? And then we presumably got it back from some output stream, and we compared that 7, the expected value 7 was the actual value 7. Yes? We were exploring the idea that perhaps a more rigorous validation would be that instead of getting just the value number 7, I could perhaps have a string representation of that same result and validate that the result might be an actual string, that 3 plus 4 equal 7, right? And then I could compare the string against the string and validate that the 3 that I sent and the 4 that I sent somehow didn't get munched up in flight. Okay, that nobody added anything, nobody transformed anything, right? And the resulting was a little bit less general, but at least it's something that I can validate and compare and make sure that yes, indeed, this is what I was expecting, right? So let's take that a little further. Instead of just considering a single interaction, we might want to have an entire conversation or entire dialogue with a calculator, right? Especially if this calculator has state. That state might change over time, right? Maybe it's an account or something that I'm depositing, I'm withdrawing, and depending on the initial state, if I deposit $10, then well, it should be whatever the initial state plus 10, right? And so on and so forth. If I withdraw, add, and this is a conversation back and forth between a human being interacting with this system, right? In a particular dialogue. So let's look at what a dialogue might look like. If we're testing a calculator. Now, testing a calculator in a long dialogue of entering some inputs and then getting some outputs back and then some inputs again and then some outputs, it could be fairly complex, right? To test this long winded dialogue, right? So how would we do that? It would be very hard to. It would be perhaps very complex to keep track of which outputs would go with which inputs, right? That we would need to somehow keep track of. This was the dialogue that I sent at 2 plus 2, and then the result was 4. We would need to somehow synchronize and say, well, these inputs go with those outputs, right? In a long-winded dialogue of the user interacting with the calculator over a long period of time. So how would we deal with that? Well, first of all, we need to identify that in a controller, right? In a synchronous controller, there is a fairly well choreographed conversation, right, between the controller and the human being or whoever's interacting with this, right? The controller prompts the user, the user responds to that prompt, and then the controller prompts the user again, right? And they interact in this dialogue. So using this simple understanding of what the choreographed conversation between the controller and the user, perhaps we can try and model that interaction. For instance, the interaction might look like something like this, right? First, the system wakes up, greets the user, welcome to calculators are us, and gives maybe some prompts saying on how to use the system, perhaps some documentation, and then the user can start using it. They type 3 plus 4, and the system responds with a 7, and then they're prompted again, right, to provide another conversation and says, well, 3 plus 7, and the response is 12, and finally the user just quits, and that might be the extent of the conversation, of the dialogue, right, between a user and its counterpart. If we try to categorize what these interactions might look like, we see that we see that some of them are coming from the system, right? And they're just printing a welcome, printing some instructions. So the ones that are in light blue are categorized as the output or printing of the system in that portion of the interaction. Whereas the yellow ones are representing the input that a user might give the system, right? And they take turns, right? So that's why we call this a synchronous, right? I talk, then you talk, and then I talk again, right? And there's no interrupt. There's no one talking out of place, as opposed to an asynchronous, right, where the user is free to click on on a fire button at the same time that they're jumping around and they're interacting and doing all sorts of things that are happening at random times. And the system needs to make sense of all of these interrupts, right, and synchronize them somehow. Whereas this is like take turns, right, like a game where you take turns. So once we've categorized this, we need to think about, well, how do we capture this? How do we model this? It looks like there's two types of interaction: the interaction where the human being enters some kind of input, right? Perhaps as a single input line, the 3 plus 4. Whereas the output of the system might be multiple lines, right? It might be a welcome, some documentation, some actual response to the stimuli. So it could be not just one string, but it could be several output strings. Yes, several output lines. So these seem to be fairly good representations of those two types of interaction. One is an input, one is an output, and internally we might implement them as a simple string value that keeps track of that input that the user is typing at the keyboard. And the constructor just takes in that input and just copies it over into your local variable. For the print interaction, it might be that just slightly more interesting, right? Instead of just one single string, it could be multiple strings, right? That it outputs a welcome, some documentation, maybe some output. So multiple lines, and we're just copying here into an array of lines. Yes, right? Now. Because these are we want to what we want to be able to represent here is not just one single interaction. We want to represent a collection of interactions where some of them are inputs, some of them are outputs. So to be able to collect them into a single collection, right? They need to be able to be of the same type, right? We cannot put an array, create an array where some values are of one type and some of another type. So to be able to have them be of the same data type, we create a parent interface, right? We call it the abstract interaction, right? We don't know some generic type of which both classes can then implement, right? If they both implement the same interface, now it can put them in the same collection. Yes. So here's a parent interface that will allow us to implement the interface. The two classes can implement this interface so that we can treat them as generic interface. Now, let's not look at the signatures, the body of the interaction, not just yet. Just in a minute, we'll come back to it in a second. But the intent of implementing an interface is so that we can collect them in some common array or some common collection of these things, right? So that we can iterate over them, right? Presumably, the controller could iterate over these interactions and parse the input, pass it to the model. The model can then actually add the 3 plus 4 or 5 plus 7 and whatnot, right? And come back with the results. Yes. So the collection, the controller would iterate over these various interactions. So we have the two types implementing the same interface. So now we're free to create a collection of interactions. So we have here we're using reverse Polish notation, plus 3 4 and plus 5 7, as opposed to 3 plus 7. So it's a prefix notation. So we have an input interaction, a print interaction, an input, print, input. So we can now have a representation of a long discourse, a long dialogue between a presumed user and the results that we expect. Right? We can then take this as perhaps the expected behavior. This is what we would expect, right? And then run these inputs into a real model through a real controller, and the controller would spit out the results, and we can then compare. Did you get a 7? Did you get a 12? Right? Given these inputs. So this would allow us to now take a look at this array, right, of interactions as if it were a script, right? We are programming, right, a finite state machine that is going through this, parsing this, right, and then it's and then depending on whether it's an add or a multiply or division or whatever, right, depending on the various events that are streamed into the system, right, it decides to go one way or another. And give it this. So basically, we're building a script. Yes.
Why is it that only the input interactions have a new line after them?
It's because of the way we're gonna use a string buffer, and string buffer expect these. Yeah. Whereas a print interaction has many strings that are calculated, and we add the new line at the end in the implementation. Yep. Right, so let's take a look at, we're considering this as if it were a script, right, and a particular script that we can run through and verify that the script ran correctly and it behaved as expected. So let's take a look at this as implementation of a script.